Hello, you're welcome. Let's solve for the value of x in this beautiful equation. So now we're going to have this to be 2 to the power of x. I will write this plus x equals what? Equals 20. Alright, so from there, I'm going to transpose this. I'm going to transpose x to this side. So that will be 2 to the power of x equals 20 minus what? Minus x. Alright, so from there, the next thing we're going to do, so I'm now going to divide both sides by 2 to the power of x. So if I divide both sides by 2 to the power of x, like this, both sides by 2 to the power of x, I'm going to have what? So I'm going to have 2 to the power of x divided by 2 to the power of x and equals 20 minus x divided by what? 2 to the power of x. So now from there, you see that this, we cancel this. So we're going to be having 1 equals, then here we're going to be written as 20 minus x, then multiply by 2 to the power of minus x. Or I should write it like this, 1 over 2 to the power of x. Alright, so from there, so I'm going to have 1 equals 20 minus x, okay, then multiply by 2 to the power of minus x, because from the law of indices, when you have something like 1 over a, this is going to give us a to the power of minus 1. Alright, so that's the idea I use. Okay, so from there we're going to have 1 then equals, so we're going to have what? We're going to have this 1 equals 20 minus x, then multiply by 2 to the power of minus x. So the next thing I'm going to do, I would like to multiply the both side of this equation by 2 to the power of 20. We're going to have 1 multiplied by 2 to the power of 20 equals 20 minus x. Then I have multiplied by 2 minus x multiplied by 2 to the power of 20. Alright, so from there, so the reason why I multiply both sides by 12 raised to the power of 20 is because I want something like this, okay, in the bracket to be something we have at the what? At the power. So now we're going to have what? We're going to have 2 to the power of 20 then equals 20 minus x. Then I have what I have here to be 2, because 2 raised to the power minus x and 2 raised to the power of 20, so they are having the same basis, so we can have the power to be 20 minus or 20 minus x. So can you see now? And that is our idea, to make sure that this and this are the same. Alright, so that's why I multiply both sides by 2 to the power of 20 before. Okay, so from there, the next thing we're going to do is that let me rewrite the equation by having 20 minus x, then multiply by 2 to the power of 20 minus x. On the left hand side, I have 2 to the power of 20 at the right hand side. So now from here, the next thing we're going to do is that I would like you to recall that when you have e to the power of ln a, this is going to be a, because e and ln, they are inverse to each other. So therefore I want to write 20 or 2 to the power of 20 minus x, like that. So it's going to be e to the power of ln of 2 to the power of 20 minus x. Alright, so from there we are going to have what? We're going to have 20 minus x, okay, then multiply by 2. So we are not going to write it like that, we are going to write it in form of ln, that is exponential ln of 2 to the power of 20 minus x, then equals 2 to the power of 20. Alright, so from here now, the next thing we're going to see, so we are going to, if you remember from the law of logarithm where you have log of a to the power of b, so this will be b, the b will go down, then we'll be multiplying log of a. So we're going to apply that. Alright, so from there we're going to have what? We're going to have 20 minus x, okay, then e to the power of 20 minus x, then ln of what? Ln of 2, then equals 2 to the power of what? 2 to the power of 20. Alright, okay, so the next thing, we still want to maintain that the coefficient of a and the power of e should be the same. So what we need to do to the both side of the equation is to multiply both sides by ln of 2. Okay, so we're going to have ln of 2 multiplying, or let's say 20 minus x, ln of 2 is multiplying like that, then e to the power of 20 minus x, okay, 20 minus x, 20 minus s ln of 2, then equals ln of 2 multiplied by 2 to the power of 20. Alright, so from here, so we can now see that we are having the coefficient of e and power of e to be the same. If you look at this side now, you can see that they are now having the same thing. So now by doing that, we are now going to recall state that when you have Lambert function of a function a to the power of a e to the power of a, so this is going to be what is going to be a. So now we're going to apply this here. I mean, we have 20 minus x ln of 2 e to the power of 20 minus x ln of 2, then equals, now before we even apply this Lambert function, so we are going to use it, but before we apply Lambert function, so I want us to do something here. So here you can have something like this, having what, let's say we have 2 to the power of what, 2 to the power of 4, okay, multiplied by 2 to the power of 16, then ln of what, ln of 2. So now this 2 to the power of 4 multiplied by 2 to the power of 2 is what? It is 2 to the power of what? Is 2 to the power of 20. Do you understand? It's 2 to the power of 20. We try to split like that. Understood? So by doing that, we're going to have 20 minus x ln of 2 e to the power of 20 minus x ln of 2, then equals. So we can now have 2 raised to the power of 4. This 2 raised to the power of 4 is 16. Okay, so we're going to have 16 ln of 2, then multiplying 2 to the power of what? 2 to the power of 16. Understood? So from there, we're going to have what? 20 minus x ln of 2 e to the power of 20 minus x ln of 2 equals. Now here we can rewrite this also as 16 ln of 2 multiplied by e to the power of ln of 2 raised to the power of 16. So now the idea we use up there, e link, they are inverse of each other. So but because we want this to look like this, all right, so that's why I try to introduce e ln to the right hand side too. So from there we're going to have what? We're going to have, now this right hand side will be 16 ln of 2 then e to the power of 16 ln of 2. Can you see that? Then we have 20 minus x, then ln of 2, e to the power of 20 minus x, then ln of 2. So from there, so we're going to have what? We're going to have this to be applying what? When you apply w, Lambert function. So we're going to have this to be 20 minus x, which is going to give us 16 ln of 20 minus x ln of 2. So from there, we're going to see that ln of 2 is common to the both sides. Ln of 2, we cancel ln of 2 here. Then we're going to have 20 minus x, 20 minus x, then equals what? Equals 16. So from there, so we're going to have 20 minus x is going to be 20 minus 16. I'm going to have x to be what? X to be 4. So x is the solution to the problem. Alright, x is the solution to the problem. If you enjoy the class, kindly share to your friends so they can learn from this. Thank you so much for watching.